It's probably a monoxide detector, I would guess,
It blinks a lot for that.
just because it kind of looks like that.
I don't know, maybe I
Maybe
was
it's-
always,
in the front row, so you
I was always sitting in the front row, so I was right ahead of it.
It could be talking to the fillings in my teeth, though, I don't know.
Well, we got this, which looks like an infrared sensor, and then that, and it's like,
That's just so they can watch
it's a lot of blinking for a.
But I know that thing is a CO2 monitor. So they got curious and I breathed heavy on it for a minute and the number skyrocketed. So I started like trying to get it to go down again. All right, data structures. So data structures are one of those three keys to being a really, really good programmer. Right, the kind of programmer people fight over and try to give you more money than anybody else in order to hire you. Okay, so my claim, just from what I've observed, three keys to being a highly successful programmer. The first is a good command of data structures. Second is effectiveness at debugging. The third is the ability to do rapid prototyping. Be able to take a problem and come up with a quick and dirty version of it that works right away, and then build on that. Okay, and we'll have some practice with all of these things in this course. Data structures being the most prominent. So what is a data structure? Basically, it's the idea that when we write programs, we're trying to process information, okay, data. And to the computer, the data is just a pile of bits. It's just a bunch of ones and zeros. Now, there's a bit of organization. They're organized into groups of 8 or 16 or 32 or 64 chunks to make what's called a word. But really, it's just a bunch of ones and zeros. It's a bunch of capacitors that are charged or discharged to store a 1 or a 0. And that's it. But as programmers, we see data in more sophisticated terms. For example, we see that pattern of bits and we might think the number 5. To the computer, it's just 8 bits. But we might say, okay, but these 8 bits are part of an 8-bit integer stored using 2's complement weighted positional notation, and so this represents the number 5. Or this, which is the number 65, might mean the character uppercase A. So we already have some notion of treating data as more than just a big pile of ones and zeros. Now suppose you were asked to write a program that could take a series of integers and calculate their average and return that as a function value. And don't worry about rounding, just do sum and divide with integers. And you've never heard of an array. Don't know about arrays. You don't know about varargs. If you know what varargs are, forget about those. So how would you write, markers are dying quickly. How would you write a program to compute the average of, say, up to 5 numbers? You what?
Use the assignment account.
Yeah, but how do you pass your numbers to this function?
Do you want to do it one entry at a time until you stop taking entries, or do you want to do it all in one
I
line?
just want to pass it up to 5 numbers. I may only want to take the average of 2 numbers. But in the absence of an array, I got to do something like this. Right?
What's the last one?
Length. So that tells me how many numbers I actually care about. And my code is going to look even worse. Well, if I only care about one number, I'm going to assume it's the first number, I'm just going to return that as the average. But if I was given 2 numbers, first two numbers, divide by 2, and return that. And so on. Horrible code. It works.
I forget, can you declare, oh gosh, what's the exact word, when you initialize a value, can you initialize them all to 0 when you declare them up there, and then just whatever gets passed through, gets passed through?
So you can just add them all together.
Yeah, and then like make the length the first one, and then just say n1 equals 0, n2 equals 0, and then you just go,
I mean, yeah, maybe, and we wouldn't do this, but technically, when you call average, you've got to pass it 5 integers plus a 6th integer.
I'm just thinking of short ways, I'm
Yeah,
not
yeah.
thinking of something for C#, let's see.
So this is goofy, right? This is not something we want to do, but if you don't have an array and you don't have something fancy like variable arguments or something like that, this is what you got to do, okay? But this is where the problem is coming from. Because the numbers that we're passing to this are not just 5 integer variables. They have something to do with each other. They're all part of a set of numbers that we want to average. And it would be nice if we could somehow treat this collection of numbers as a single entity and get to the individual pieces of that entity in order to access those individual numbers. That's what an array is. Okay, an array is a really rudimentary type of a data structure. So when I say integer nums bracket 1000, I can use the word nums, N-U-M-S, as an argument to a function, for example, and it means 1,000 integers. And why does this work? It works because when I make this integer declaration, somewhere in the memory of the computer, it will find a location where it's going to store nums bracket 0, the first number in that collection. And at the next set of memory locations right after that, it's going to store the next number. And at the next location after that, it will store the next, and so on. And when I say nums, N-U-M-S, that means the address of this first element, nums bracket 0. Now, if a subroutine knows the address of the first element, it can find the address of this element by just adding 4 or 8 to this address. And it can find the address of this by adding another 4 or 8. If it's a 64-bit machine, it'll be 8. And it can find the address of entry 500 by adding this 8-byte displacement 500 times. So take the address of this number, add 500 times 8, and you get the address of element 500. So this is an example of a data structure. Okay, it lets us take these pieces of information and say these go together somehow. And so we're just going to call it by this name, and you can get to all the individual pieces through that name. But that's still slightly suboptimal. So our average routine now looks like this. And are you comfortable with this integer star idea for an array? Right, because when we say nums, under the definitions of C, this means the address of the first element. Okay, nums is the same thing as address, nums bracket 0. And down here, when we pass nums, we're simply saying that's the address of an integer. And C lets us then say things like nums bracket 0, nums bracket 500, or more generally, nums bracket a variable. And we can get to those pieces. So if you're not up on passing arrays, practice, right? And that's one day program too. So that's a chance to work with that. But this is slightly cheeseball still because we're trying to average this array of integers, or we want to print out the elements in that array, or we want to calculate the standard deviation of the elements in that array. So we might have void print integer star nums and integer length. Or we might have an integer standard, do you know what standard deviation is? It's just a measure of variation of a set of numbers. It's like the average square divided by a square root of something. It's fun. So I can do standard deviation of those nums and the length and so on. But every time that I talk about this array of integers, I also talk about its length. And I've got to treat those two together. If I just pass this array to something, there's no way for that subroutine to know how many things are actually in this array. I can tell it it's an array of 1,000 integers, but does it actually have 1,000 values that I care about? So think